copy anything down or take any pictures or anything. Okay, just let me know.
Okay, yeah, yeah. Yeah, I will take a screenshot as we go along.
Okay.
Yeah.
Did you want want me to show you one and two again then?
Yeah, sure.
And I'll make my I don't know if you can see all of that.
Oh, yeah, I can.
Got it? Tell me when you have it.
Yeah. Um all right, I got it.
Okay. And then let me check to see which others missed because we could probably do a whole page. I don't think there was. So one and two, you got 5 out of 10 points. So if you can see like the scorings here on the side,
Mhm.
3, 4 were correct. Number five was incorrect. Let's um, number five was tangent inverse of zero. Make that bigger. So on your unit circle, oops, this is where I get all crazy with my tabs. Okay, number five. So from the unit circle, a, a tangent of zero would either be um, 0 or pi, but since tangent inverse is only defined from negative pi over 2 to pi over 2, do you remember that? It's only quadrants 1 and 4.
Oh, okay.
So your
Yeah.
answer would be just the 0,
0.
which is
Okay.
option C. So if we were doing a solving an equation, then you would put every possibility. But since it's saying evaluate, find the exact value, you had to use those domain restrictions.
Okay. So, and I have a question. In like, what instances do you get like multiple answers when you're evaluating?
So if this problem had said, if it was an equation that said solve, and then it said tangent of -1 um, 0 equals, actually, it would have been like this. -1 and 0 equals x, like that. So then you're trying to find x or theta, or if this was the angle, then if it's in an equation, you would put 0 and pi because you go all the way around. Because this would have said solve, and it'll say for 0 less than or equal to x less than 2 pi.
Okay. So if it doesn't specify that, then it
Yeah,
wouldn't.
if it just
Okay.
if it just says find the exact value, and there's using these inverse ones, you'd have to use those restrictions. But if it said like these questions down here, 11 through 15,
Yeah.
you're going around one revolution, the entire unit circle.
Okay. Yeah, that makes sense.
Okay. Go back to 6 and 7. Those are right. Number four, number four. Looks like this is hard to see, but number 9, you got 4 out of 5 points because of the radical on the denominator. Always rationalize any fraction
Oh.
has. So you would do,
Oh. Okay.
x over, this is your answer,
Mm-hmm.
like this.
Okay.
Yeah, and then you would
Yeah.
get x times 1 minus x squared over 1 minus x squared. This would be your answer. So there's just the
Okay.
one of rationalizing. And it looks like both 9 and 10, that's what happened.
Okay.
Usually I take off 1 point for that. Yeah, 4 and 4 out of 5.
Okay, that makes sense.
Number 11 and 12 looks like completely incorrect. Let me look at it.
Yeah, these are the ones where I was kind of lost. Like,
A little confused.
yeah, just really confused.
Okay. Oops. Your steps. First step. Oops. Correct.
Oh.
Okay. I'm going to give you some partial credit on this because all of this, if you can see my cursor, all of this is correct.
Okay.
You have your unit circle?
Um. Yeah, I'll pull it up.
Okay.
All right, I have it up now. Yeah, I have it up right now.
I don't know why I can't find my document camera thing. Okay. I'm going to have to close it and open it again. The document camera is being weird. But while I'm doing this, there we go. So work. You've got sine of theta equals negative root 3 over 2.
Mm-hmm.
So when you look at your unit circle, negative root 3 over 2 on the y-axis down here, you see it?
Yeah.
The sine is the y-coordinate,
Oh, okay.
which is 5 pi over 3, and then the other one is on this side, y-coordinate, so
Hmm.
before 3 or 5 pi over 3.
Okay. Yeah, that was. Yeah.
Were, were you thinking x-coordinate?
Yeah, I definitely mix it up
Okay.
there.
Well, this is why I'm glad you're here to check because
Yeah.
I'm gonna go ahead and give you some partial credit on that because you've got everything down. Number 11, 3 points. That was 11, yeah. And let's see what happened for 12. Maybe it's the same thing. Do you have your x's and y's fixed? No?
Might maybe.
Maybe. Let's see. So, oh, okay. This one was incorrect in the steps. So
Okay.
it looks like, show you mine. You subtracted 3, which is fine. That's correct.
All right.
Then the 9 minus 9 cancels. That's
Mm-hmm.
correct. But then you
Mm-hmm.
still have negative root 3 over 3.
Oh, okay. Yeah, I didn't carry it over.
The denominator, yeah, that doesn't go away. So,
Okay.
and I will do, let's see, because your first two steps were correct. So just the first step. Okay. Number 3, or I'm sorry, 13, it looks like you got 9 out of 10 points. Let me see what is missing. 13. 2 pi over 4. Why did you put 2 pi over 4? This right here, I'm not quite sure why you have a 2 pi over 4.
Hmm.
A pi over 4. Check your unit circle. For tangent of plus or minus 1, these three are correct. 3 pi over 4, 5 pi over 4, and 7 pi over 4. It's correct.
Okay.
First one should just be pi over 4. And you want to
Hmm.
make sure your unit circle that you're using is correct, which is, so it's the one here, that should be pi over 4.
Oh, okay. Yeah,
Yeah, we
yeah.
accidentally went. The
I
thing
think
is
I
that,
just I think I just wasn't thinking at the time.
yeah. And unfortunately, if you write 2 pi over 4, that reduces to pi over 2, which makes it completely wrong. So I give you, I think I did 1 point off or something.
Yeah.
9 out of 10.
Yeah.
14 and 15 looks like both. Let's see.
Yeah, just the last few problems I just didn't know how to do.
Yeah. 15. This is all correct. So I'll go back to 14 and I'll show you how to do that.
Mhm.
Let me have you look at my work
All right.
for 15. Notice it's kind of weird, but can you see it?
Yeah.
So I factored, but you used the quadratic formula, which is correct. So
Okay.
in the here, you got x equals 1 and x equals 1 half. But the x is really cosine theta.
Oh, okay.
Okay? So here,
Wait.
in your quadratic form, this is really 2x squared minus 3x plus 1. So then after you get the two answers, you get 1 and 1 half, you have to set them equal to cosine theta and then get the angles from there.
Oh, okay.
Okay?
Yeah, I need
So
to.
cosine theta of 1 gives 0, and cosine theta of 1 half gives you angles of pi over 3 and 5 pi over 3.
Okay.
Okay? So you just had the whole second kind of section of it. And
Hmm.
again, I'm going to give you some partial credit on that. That was 15 because you did halfway and then you just have to keep going. Okay, sorry. Oh, goodness. All right, here's 14, and it's nice and zoomed in. So go ahead and take a picture, and then I'll explain.
All right. Yeah, I will. All right. I took a picture.
Got it? Okay.
Yeah.
So what I'm going to do is I'm just going to cover this up. There's
Mhm.
nothing of the sign.
Mhm.
So basically, it's the same. The sine of whatever this angle is
All
equals
right.
2 over 2. So then I
Okay.
do a circle, and the
Yeah.
two angles that give you 5 pi over 4, I'm sorry, two angles that give you a sine of negative root 2 over 2 are these two, 5 pi over 4 and 7 pi over 4.
Yes.
Take this whole chunk, this whole expression, and set it equal to each of those angles.
Oh, okay.
And then now you're solving for the variable, which is theta. So then over here, I subtracted 7 pi over 4 and got negative 2 pi over 4. Then I divided by negative 2 and got theta equals pi over 4. And then on this one, subtract 7 pi over 4, you get 0. Divide both sides by negative 2, theta equals 0. So here are your two angles.
Okay. Yeah.
Okay, let me do this real quick. That one, unfortunately, didn't quite know. So all of these, I'm going to redo your scoring. It'll be a little bit better, and then that way when you do the retake, You know that it's. Okay, I'm going to stop presenting. So for a second,
All right.
and I did not. Oh wait. I mean, it's still definitely not your best.
Yeah.
I mean, it sounds like it was kind of little things. Unfortunately, some of these questions are, big point problems.
Yeah.
But hopefully, when you do a retake, it'll go right back up. So
Yeah.
now it's 62, and then I'm assuming you want to retake, yeah?
Yeah, I do want to retake.
Let me add you. Okay. Okay. So that's it. So on Wednesday of next week, you'll be I will schedule the retake for you from 8:35 to 11:35, the same time, unless you tell me another 3-hour time window that works better. Because retakes I can schedule kind of on an individual basis.
Okay.
That's a conflict. Um, I can change it.
Um. Okay to do it on potentially like like after school Monday.
Well, let me go back. It has to be on Wednesday.
Oh, it has to be Wednesday. Okay, that's fine. Yeah, that's fine.
I just want to, because I want all retakes to be done on Wednesday. They'll schedule them. What I was saying is I can do a different 3-hour time if 8:35 to 11:35 is not a, like some kids have other things they have to do or
Yeah.
whatever. Or if you want to just do it a little bit later, but that's that way if it's done at 8:35 to 11:35, I have a good chance of time to grade it and everything.
Hmm. Is it? Would it be fine to do it at maybe 12 to 3 afternoonish
Yeah,
to eveningish? Yeah.
yeah, I can do that.
All
So
right. Yeah. Thank you.
12 noon. I just have to write that down and then I'll schedule it. This is Wednesday, 5 May 19th. Okay, sounds good.
Yeah, that sounds good. All right. Thank you.
You're
Yeah.
welcome.
Yeah. Thank you
Bye.
so much. Yeah. Bye.
Mhm.
I'm worthless.